this T-block today. We've got everything magnafluxed on this block. Everything's checked out, got a good core. Everything seems satisfactory to work with. On the work table over there, we've got the pistons. We've already went through them and mic'd each individual piston to verify its size and quality. Look like some good quality parts we're working with today. We're going to set this up into this boring bar and get everything fixed and in place and get everything ready to do the boring. Give me just a minute here, we'll get it all set up under the bar and be right back with you. We'll do one more bit of checking here before we start filming again. Okay, what we've got here, we're going to set up the boring bar mics, and we've already been through and calibrated and checked all of the sizes of these pistons. We've done our math on paper. We've got our recommended clearances involved. So I'm going to set up a mic and set our micrometer for our cutter. We've got all our math done on paper. We just got to get these numbers together before we get over there to the boring bar. So let's see. We'll move over here to the boring bar. Get everything centered up here. Get our cutter down there close. Locked in. And away it goes. Now we'll let this go all the way through this cylinder. This is the worst cylinder on the block. If we have to size up from here, we can. We just need to take a look at it once we get clear of the block. Boring bar does its job pretty quick. Getting all the rough material out of it. We'll get to honing the cylinder a little bit later. But for now, we've just got to get these holes roughed out where we can see what we got. We'll set a stop on it. We can watch it through the next cylinder and know the progress that it's making. Let's take a look and verify the cylinder. I don't think 40 is going to make it either.
No, 40 won't do it either.
No.
Okay.
We may need to go on that. You got a, what do you got after 40? Got a 50?
60.
A 60?
Yeah.
Okay.
Yeah.
Let me add 30 more to our mic and let's go back through it.
Okay.
It'll be clean there.
Okay. Let's see here.
Let me just.
Yeah, you're good.
I'm just going to tool up and reset the cutter, and then we'll go through that cylinder as if it worked. Yeah.
Okay.
Spots or anything, you know, as far as
interrupted.
Yeah, I mean, I don't have to hold on to it or nothing, but
I understand.
A lot of this job is feel and sight. So
And believe it or not, hearing.
a lot of hearing. Yeah.
You got to hear what it's doing.
Yeah. Yeah, what we're doing is we're going to go ahead and get these 4 cylinders bored. We'll get that much of it done today. We're going to cut a nice chamfer on it, and then probably tomorrow we're going to pick up and be on another machine. And I'm doing this Mitsubishi diesel block and this 23T block together. We've just finished our first cylinder. We're going to move over to another one and repeat the process.
Well, how do you tell me about centering?
Most boring bars have centering fingers, and these fingers come out underneath the boring bit and find the cylinder and center up off of it.
Okay.
And that's fairly accurate, probably within a thousandths or two of the diameter radius of the cutter. So it's all calibrated. Now when I've set this cutter up, I've left this cutter back about 3 or 4 thousandths from our desired finish. And when we get to another procedure with the finish in the cylinder, we'll have that material to work with to get right to the size that we're after. While that's running, I'm going to go ahead and set a cutter to put a nice chamfer on it where we can get the rings in and out of it. We're going to set up a cutter now, put a nice chamfer at the top of the cylinders. That way the rings will be easy to get in and out of the block. Okay, we've completed 4 cylinders, got a chamfer. This is first step in repairing a block. You might want to bring it over here and look at some cylinders and take a quick shot. We'll meet up with y'all on the next machine for step 2 of this block repair. And thank you. We're back on the project. Back to our next step. We're going to put some hardened valve seat inserts in. I've already put one seat insert in that we could have a comparison to see where we're going and where we're coming from in the process of restoring the block. Hardened seats are very important for unleaded fuel today. This old cast iron block would not run long on unleaded fuel. In fact, that's a lot of the valve seat wear is from the unleaded fuel in its life. But this will bring it up to modern specs so that the unleaded fuel won't be bothering anything. Have a good long life. So we're going to back up and level up and check up on everything, make sure we're at our block is ready to start machining on. Then when we get to that point, we'll be giving you bits and pieces of the process of cutting and installing and finishing the seats. And so hang tight, here we go. We'll see what we can get done. We're going to be setting up our block here, getting everything back into kosher to put these inserts in. And a lot of this setup requires a precision level. We try to run everything as precise to maintain our factory angles and parallels and everything involved. A lot of times you guys will want to free drill and oversize these valve guides. It is best to have them parallel with the block, and then the guide board that keeps the valve on its original geometry, which is very important on the back side down there with the lifter and ultimately to the camshaft. Efficiency of an engine is that all the geometry stays in line, and it reduces wear. A lot of these angles get off, valves running trying to push on the block instead of pushing open. It just creates valve guide wear, short life, sometimes can lead to some scuffing and galding. But we're squared up and ready to go. We're going to move on and start putting some seats in. We've got our hardened seat inserts. You can see it's made of a very high quality material. These come in all different sizes. They're used to repair any kind of valve seat work. All modern engines typically will have a hardened seat, especially exhaust side. In this case, we're going to do intake and exhaust to repair everything. This is a fixed cutter. Fixed cutter means that the cutters are set to a fixed dimension, which will have the proper press fit for everything to go together in the block. We've got our pilot and our guide. This is a cylinder head and guide machine. Its only purpose in life is to put guides and seats in. That's all it does. Start with our starting cut. We're going to gauge our seat. This is how we know where we're going. We just let the cutter do the work. There's our stop. We're down. We'll move on to the next one. Always wear eye protection. At least know where the chips are going. It's important that this be done. You know, mostly professional people need to be working with this. Bill, I don't know if you can get in here and look. Got pretty good light right here. I want to point out one thing. The way the exhaust ports are made on an old T block, you can see where the exhaust port comes in right here. You can also see how high the port runs up under the seat. It's very important when we do the exhaust seats that we don't break this floor. On your intakes, you can see how much material you have underneath the seat, quite a bit. There's a good base for that seat to set in.
There's not much room there, is there?
There's not much room there. We got to just go to that point and not break through that floor. That keeps a good base for the seat, and whatever's hanging out of the block we'll deal with later. Just because the seat's this dimension doesn't mean that we have to use it all. If a guy was to just say, hey, we're going to put this seat in, it's got to go in regardless, he's probably going to ruin the block. What's going to happen is whenever it falls through the floor, as thin as this port is, eventually the block will crack across right there.
Right, yeah.
And by that, you know, cracking across there, the blocks it's catastrophic. It's done.
Right.
Yeah. So just a few tips and pointers. We're going to set up and do the exhaust right now. We've got our intakes cut, so we'll back up and do our exhaust. And these are a little bit tedious. We just work.
Yeah, I see.
See, we've left the integrity of our block. Got this floor here for support. It may not be as deep of a pocket as what the seat, could be.
Right.
But we've got to work back to the block.
Yeah.
The block first. Always save the block first.
Yeah.
Okay, we've got our seat pockets cut. We're going to take a break and blow this block out, clean up some tooling, and we'll be right. Our seat, when this material's gone, you can't go very deep.
Yeah,
this is
what it is.
It is what it is. Yeah. I'm gonna put a little hardener, or what do you call it? A sleeve retainer on it.
Okay.
It's about all you can do. There's none of them perfect, and
Well, what do you want?
yeah, they were
Almost 100 years old.
they were perfect 100 years ago. Is it going?
I'm good. All right.
Okay, we're back. We're going to be installing these seats. Some of these exhaust seats we didn't get to cut as deep as we normally do because of the way the exhaust ports are made. I'm going to use a little bit of a Loctite product called sleeve retainer. This will just help bond the metal to the seat. Has an extreme heat rating. Exhaust is all we need to worry about. We just apply a little bit of sealer there and get these seats put down. We've got our exhaust seats that we've had some block eroded away from it, and the problem with the floor of the seat pocket where the port comes through. We've got our seats up just a little bit. We're going to go back in now and trim them down to make them a suitable level for reconditioning the deck. Just verifying that the seat's below the deck level. Things at a surface level. We'll set up now and we'll rough cut the seats. This is an adjustable cutter. It's a setting fixture for it. We're duplicating the valve. I've set the cutter where I want it. I'll back up here and show you the valve. Okay, cutter set. This is going to show us our angle. Pointer is where we want it to seat on the valve. We want to be on the bottom third of the valve to do the valve properly, to get it back in there. And we'll just double check it one more time here. Comes right back to the bottom of a 45 where we indicated from the valve. Everything's in position. So when we cut our 3-angle valve job here, we're actually going to be duplicating the valve into the seat instead of the seat to the valve. Verify our block before we go any further. We did some hammering on the block to put the seats in. Bingo. So we're back to that one plane where we talked about everything staying parallel and in the proper geometry back to it, and the valve will fall right back into the seat, be as true and square as it can be. Okay, what we're going to do now is we're just going to verify our seat in contact with our valve. Right now is the time to correct anything before we get out of the machine with all the setup time and everything. So we're going to verify this valve. Put a small amount of lapping compound on the valve. And yes, we still use these tools every day. It's a really fast way to get a picture of what we need, picture of where we're at, and to verify our valve and seat. As you can see, we've got a bottom third of the valve.
Yeah.
We still see some of our valve face. We're at that bottom third. That actually, we're utilizing the majority of the valve, all the valve that we can for the life of this engine. It's real important to have the seat up under the valve to help it cool. Even though the exhaust temperatures are as high as they are, believe it or not, that valve will live probably 3 times as long as if compared to if the seat was up on the valve. So we're all in good shape. Got a little bounce. That's what we want. Guides are good and free. Valve guides are done. Valve seats are done. Valve face angles are done. Cylinders are bored. Our next step is to be machining the top of this block. We're going to take and square this up, get rid of all the imperfection and all the years of run time, and improve it for new gasket sealing. So we're going to move on to our next step. Everything's completed right here. Thank you. A little bit about what we're doing. We've got our cylinders, guide work, seat work. Everything's prepared on this block. We're now going to try to recondition the top side of it, the deck, for new head gasket. Take care of any imperfection in years of running and distortion. This block here is pretty much a mess. It's gonna need this really bad. I've got everything set up, everything squared. It takes a little to do this. We didn't show a lot of this. It's fairly time consuming, but we're at a point now we're within 2/1000ths from corner to corner, front to back. We're less than 2/1000ths. That's about the best the block's going to let us work with. We'll set in here now. We'll go to cleaning this up, and we'll just look for some good uniformity. Something we feel that a gasket would have no problem, seating on, hanging on to. Whatever we got to remove, we just got to remove. At this point here, we just, again, trying to save the block. So here we go. We'll work with it slowly and see what it looks like. We'll make our first initial cut just to give us a good picture of what we got to verify our setup. So far it's looking like what we want. And give y'all folks a good idea. This is just our cleanup pass. We've basically not really started cutting anything yet. As you can see, we're corner to corner to corner. The block looks like it's a little bit low in this area right here. As you can see, a lot of this area around these valve seats in its previous life, it wasn't up to par, especially when you got head gaskets less than an inch from the outside and water going to be passages on the top side here. It's very important to have this side right here extremely flat and true. So we'll go ahead and fire it up here and keep it running. We'll start dropping it off of there. Okay, we've got it completed. Everything's clean, very satisfactory. The next step here, kind of important step, is to deburr. A lot of sharp edges after it's been cut, and I'll just do some deburring right quick here to That does the cylinders. We'll run around the block with just something to knock the edge down. And that takes care of that. A lot of people like to record what they've removed on the block, either by stamping the block or recording it in paperwork. I typically just always stamp the block. It's history now, so everybody will see it from here and know where we've been.
Cool.
So that concludes surface grinding. The block is now prepared for the gasket, seats, guides, cylinders. Now we've got the block. Next step is going to be finishing the cylinders out to size for the recommended clearance on the pistons, and then it's back off to the shop to have some more Babbitt work done. We'll stop right there and be back shortly. We're back again. We're going to go ahead and finish these cylinders to the proper and desired size and clearances, finishes, everything involved. Went ahead and got the block set up. Sometimes this setup is a little bit time detailing, and we've got it all set up. Machine's ready to go. We prefer this machine here. That puts us in control of what's going on as it's happening. This way we can dictate how much pressure and how fast we remove the material, and just we believe it just makes a better cylinder. A little more time consuming, but we're after the ultimate goal of saving the block and repairing the block. So we'll start in here, and we're going to rough out some of this material. We've got about 4 thousandths to go to our desired size. We'll use a rougher grit stone, remove that material and get it out of the way. Then we'll go to a different stone, finer grade, and required for ring finish and break in. And when we get to the final desired size, all that will come together. So we'll get started on this. Some of these old blocks can be kind of hard in the material they're made of. Might be a time process, might go right, without any problems. But we'll get started here and see what we can do. We'll change our stones now, go to a much finer grade of stone. That would be these stones right here in this finish would be completely unacceptable for new rings. This is probably the most important thing to an engine rebuild is round cylinders, proper finish, adequate and proper crosshatch in the cylinders. We always go back and double check our instruments through the process just to verify that we don't have an issue that mic-ed, bumped the mic, anything like that. So when we get to zero, we're at zero. That way we don't create our own problems, so to speak. All right, let's see where we're at here. Okay, we're zeroed up.